So between videos, I came in and added my canvas. I added two text elements to my canvas. I added one called score text. It has my score. I have one that's called life text. And I put lives 3. I made them both Text Mesh Pro text because I like the crispness of Text Mesh Pro. And I used a font called Space Age, which I found on DaFont if you're interested in this font. It's cool and chunky and kind of cutesy, which kind of goes with my theme that I've got worked out so far. So right now, if I were to click play, nothing happens, right? Because I haven't told it to do anything. I can hit buttons on my keyboard and nothing is going to happen because there are no scripts telling it to do anything. So we need to do some stuff to get this all set up. So I'm going to go into my prefabs and I'm going to take my player here, and he needs some components. So right now I'm just going to worry about adding the Rigidbody. Rigidbody2D, remember, don't make it a regular old Rigidbody because we've got a flat sprite here. We don't need it to be three-dimensional. The body type dynamic is fine. We don't need any physics material on it. We are in space, and as you all probably know, space has no gravity, so let's turn the gravity down to 0. These other options, linear drag and angular drag, we will change later, but for right now we will leave them alone. Basically, linear drag means anytime our player is moving in a line, there will be a frictional force that will slow it down, which we'll probably want to make it so that you can hit, go to press W to go forward, and then not have to worry about it going forward at the same speed infinitely. It will gradually slow down, which would happen in a normal movement situation. So yeah, gravity scale set to 0. We've got our Rigidbody2D, and then we are going to create a new script down here in our scripts folder. This should all be real familiar. Call it player. The player script is one we've had in pretty much every game so far, I think. So this is the script we're going to attach to our yellow spaceship, and eventually it will load. All right. So on our script here, we're going to go ahead and set up some variables. We are going to do some slightly different movement than we have done in the past. So with our breakout style game, we're looking for the mouse input and moving the paddle based on where the mouse was, right? We were checking for where the mouse's position was on the screen and then making the paddle mirror that movement. In this case, we are going to be using the Rigidbody component on the player to create force and use our buttons to tell it when to add force to the Rigidbody, which may sound confusing. That's fine. So I'm going to go ahead and serialize a field. We're going to make this field of type Rigidbody2D, and I'm going to call it player rigid because it's the player's rigid body. Basically, this will make a field so that we can drag our player's rigid body in. So let's go ahead and actually come down here to Unity and attach our player script to our player. Whenever it's done thinking about life, let's make sure it's attached. Okay, so now I have this spot right here is player Rigidbody2D, and it has none, it's looking for this component. Usually we've been dragging things from over here, but in this case we're dragging this component into this spot. We could have used get component to get access to it, but in this case I wanted to make it very clear what we were doing, getting access to it, and not having to declare it anywhere in our script. So we have access to it right there. We also need to have some serialized fields. Right now let's worry about this. Let's have a private float. We're going to call this one thrust input. This is going to be the thrust. So, on spaceships they have thrusters. So the thrust input would be whenever we push forward on our keyboard, it will let us go forward. And then we also need another private float called turn input. Now, you might be wondering why we are declaring these up here and we're not using if statements down below. And that is because we're going to use something a little bit different. We're going to be using get axis instead of get key down, just to show you a different variety of ways to do things. So back in our Unity here, if we go up to Edit, Project Settings, and then Input, over in our inspector, it changes to the Input Manager. And it should probably look like this. You click the down arrow to spit it out. Basically, the axis is a set kind of, I don't know, kind of like presets, basically. So if we were to use the string horizontal for our input, the negative button is left or right for the positive, and alternates are A and D. So basically it's saying you can use the arrow keys for left and right, or you could use A and D for left and right. Perfect. That's what we want for our turning. What we need is we also need our thrust. So vertical, negative buttons down, positive buttons up, and then it's also S and W. So AWSD basically is already assigned using this and all that good stuff. Now, in the original Asteroids game, you couldn't back up the spaceship, and I'm not sure if I want to turn that ability on or off yet, so I'm going to leave it on for now. But in the original, you could only go forward and you could turn left and right, but you couldn't, like, in the way like you would in a car back up. You couldn't do that. You just had to go forward and then like keep turning yourself and then accelerate in a different direction. I'm not sure if I want to do it that way yet, because it's just a gameplay feel thing. But if I wanted to, I could simply just take the negative buttons and delete them from this project. So I could just hit backspace and that would be gone. And that, like, whenever I hit down, nothing would happen because it doesn't know what to do with that. Anyway, that's the input manager. So back in Visual Studio, we also, let's go ahead and serialize some more fields. We're going to go ahead and make up the float values for how fast we accelerate and how fast we turn. So I'm going to call x velocity, I'm going to set it equal to, I don't know, 10f for now. X meaning side to side, or x velocity, it should be y velocity, I believe. Yeah, y velocity, because I want it to go up and down. Slow float space, y velocity, sorry. Apparently a little brain dead this morning. All right, and then serialize, nope. My inspector is also a little bit wacky today. All right, and go ahead and make one for the x rotation. And go ahead and initialize that at 10f as well. I'm pretty positive that those numbers won't stay that. I'm sure that that will be too slow, but that's all right for right now. All right, down here in our update method, anytime we're talking about player movement controlled by the player, we need to be checking every frame if they're doing something with their input buttons, right? So it's going to be in the update method. But we don't want to clutter up our update method, so I'm going to go ahead and declare that it's going to go to something called player movement, and then go ahead and set up a method, a custom method for it. So private void player movement, and open and close curly brackets. Perfect. All right. So we've got private void player movement down here. And for our player movement, we're going to do thrust input, set it equal to input dot, and you see it's got this get axis and then parentheses string name. So remember I said the string for vertical was just vertical, like so. So now it's basically saying whenever you are checking every frame for thrust input, and that thrust input is one of the vertical buttons. And what we want to do with that is make it so that our rigid body goes forward. So, let's go player rigid dot add relative force. Let me see if I can get that information. Okay, so add relative force is looking for a vector 2 relative force and +1 overload. So add relative force, and then we want our vector 2 here. So we want vector 2 dot up, basically saying go in an upward motion, times our thrust input, which whenever we are pushing one of these buttons, its thrust input is either, I believe, 1, 0, or -1. So meaning it's up whenever it's positive, it's W or up. If it's not being pushed at all, then it's 0. And if it's negative, it's set to S or down. So we're multiplying it by thrust input. So essentially either multiplying it by 0, which would zero out the calculation, 1, which means go in a positive direction, or -1, which means go in a negative direction. I hope that wasn't too confusing. We're also going to multiply that by our y velocity, which we've set up to mean our speed, and then time dot delta time. Nope, I moved down, I thought, but I didn't. Okay, time dot delta time, which makes our game frame rate independent. So we could leave time.delta time off and it might look great on our computer, but say we put it on a computer significantly faster, the player would move significantly faster. We would not have an accurate way to play test it. So we always want to multiply any of our speeds by time.delta time. So with this, it should basically be saying, whenever this is true, we'll take the player rigid body, which we've already declared up here. We're going to add a relative force and then multiply it by all these values. So this, I think, at this point should work. So let's double check. Let it. If I hit forward, I am moving forward. Hooray! Okay. So if I were to hit down, I see how it gradually slowed down. It was overcoming its own velocity. I go down. If I hold up, eventually it will slow down and then go back the other. Perfect. Okay, so this is working perfectly. It is very slow, so I definitely know that I need to change the y velocity number. I'm actually going to take it all the way up to 100. Let's see what that looks like. Maybe it feels more spaceshipy. Oh yeah, that feels more like a good speed. It takes a while to slow down, that's okay. I want it to feel a little bit floaty. The original game did as well. So I'm going to go ahead and apply that back to the prefab because it was bolded. Alright, so let's deal with our turn. So turn input, we're going to declare in exactly the same way. So input dot get axis. And remember, for our turn, for our left and right, the axis was named horizontal, like so. And then we're going to take our player rigid body, and we're going to add torque. Torque basically means you are adding a force at the center of the object in one direction. Let's go turn input for our first number multiplied by our x rotation, the speed that we decided we want to rotate at, and then times, of course, time dot delta time. So saying essentially the same thing as up here, we're looking for the input value of either 1, 0, or -1, multiplying it by the speed that we want it to go at, and then time.delta time. We don't have to have a vector 2 direction because torque has already got a definition for that. All right, this might be sluggish because, again, this is set to 10, so we'll see. Okay, so I just pushed right and it went to the left. So right now it is kind of inverted controls, which is great for first-person sorts of games, but right now I don't want it that way. So a simple fix is just take turn input and make it negative. So whenever it is a positive one, it goes to the opposite direction. So that is probably the quickest fix. Let me test this, see if it works. So I'm going to push the right button, and I rotate to the right. If I push the left button, it slows down a little bit and goes to the left. Hooray! All right. So we now have the basics of player movement figured out. After we get our player movement figured out, the next core thing that we wanted to make sure we had was that our player wraps. Basically, whenever I go off the top edge of the screen, I want to be able to reappear off the bottom edge of the screen. So right here is the top of the screen. I want to be able to pop back down here. I want to be able to, when I go off this edge of the screen, I want to reappear over here. So I'm going to move myself up here. I'm going to change my X rotation speed to 100. I'm going to apply that back to the prefab. And I'm actually in here. I'm going to erase these values because we're assigning them in the inspector anyway. So I'm just going to leave it be. Let me make sure they're still there in here, still set to 100. Sometimes when you change things, Unity does the wacky. Yep, okay, we're still set to 100. So that's good. All right, so now we want to figure out our screen wrap. So how we do this logically, I think the most straightforward way, it may not be the most advanced way, but it is definitely a functional way, is we want to say when we get to this Y position, we want to change our transform position. So this position right here is currently at Y 5.74. When we get to this part past the screen, we want to reappear down here at Y negative 5.7, right? And so that whenever we disappear, we appear to be just zooming back up from the bottom. And we want to say when our X gets greater than 9.59, we want it to switch over to negative 9.5. Okay, so looking like our numbers are going to be 5.7 for our Y and 9.5 for our X. And back over in Visual Studio, I'm going to show you a neat trick. So our player is going to get cluttered kind of fast with a bunch of different fields because we're going to add a lot of functionality to our player. And we serialize a lot of stuff so that we can see it in the inspector to tweak things. I'm going to show you a trick to make it so we can organize that a little bit. So above the things we've made already, we're going to type in square brackets, header, parentheses, quotation marks, player movement. So this is saying basically we're going to create a header called player movement in our inspector. So if we come back into Unity, we have a header now. It's called player movement. So everything regarding player movement is going to be right here, which is excellent. That's exactly what I want. So now whenever I keep creating new fields, I can give them new headers. So next we're going to make a header for the screen wrapping, and we are going to have to serialize this at least at first. So let's call this screen wrapping so that we can set this all up inside the game. We need a serialized field. This one's going to be a float value because we have decimals to deal with, and we're going to call this screen height. And serialize field. And it's going to be another float, and this one's going to be screen width. Now we could do this a little different. We could say, we could declare 4 variables here. We could have screen top, screen bottom, screen left, and screen right. The reason I am not doing that is because I think it will be just a little bit more clean to have less fields up here at the top, and because our screen is centered in such a way that whenever this is 5.7, if I make that number negative, it is exactly where I want it on the bottom of the screen. So I can just add a negative to my value and it will work exactly as intended. Under our update method, we need to always be checking if our player needs to wrap. So let's make a new method called screen wrap. Put it right here. We're going to call it, private void screen wrap, parentheses, curly brackets. All right. So we need to first declare a vector2. We're going to call it player position, so player pause, kind of like we were doing with paddle pause. where we were checking for the paddle's current position. And we're going to set it equal to the current position. We're just saying this is a variable that we're saying is wherever the player currently is. And we need to say if our transform y becomes greater than the screen height, then our player position y needs to equal negative screen height. And then we need to reset the transform.position to player position. So the way I just stated all that should give you plenty of clues if you want to go ahead and start typing. That's great. But I'm going to go ahead and type it out. So we want to say if our transform.position.y is greater than screen height, then we do these things. We need to set the player position dot y equal to negative screen height, like so. And underneath the if statement, after we've declared if this happens, then do this other thing. I'm going to space some stuff out a little bit because it's getting a little chunky in here. All right, transform.position is equal to player position. So basically we reset the player position in this if statement, and then we reset the transform's position to match that afterwards. That needs a semicolon. All right, save that up. Let's check and see if we go off the top of the screen. We should, if all goes according to plan, reappear on the bottom. Except, real quick before we do that, we need to actually give it some values. So our height was 5.7, right? So I'm going to put 5.7 in for screen height, and I think the width was 9.5. Could be wrong, but I'm not using width yet, but just for the sake of having it there. All right, if I hit up, I pop to the bottom. So, yep, working exactly as intended. So we know that that code works, and basically we can just copy and paste and keep doing it for all the other versions. We just have to make slight tweaks. So copy that if statement. We want to know if the transform.position.y becomes less than the negative screen height, and then set it equal to the positive screen height. So basically the reverse of this statement is now true. So if we go off the bottom of the screen, we will wrap to the top of the screen, because before, if we'd gone off the bottom, nothing would have happened. So that should be everything for wrapping here. Let me save that up, go into Unity. I'm going to drag my player down here to the bottom, just for the sake of testing. I'm going to spin myself around a little bit and then fly off the bottom of the screen, and I reappear at the top of the screen. Perfect. And if I spin myself, my player driving is a little bit floaty. I will mess with that more in the future, but okay. My wrapping is working. That's the point. Tweaking can come later. Let's get the functionality in here first. So, now we have to make a couple more tweaks. Instead of changing the negative and positives, we've already got that worked out, but we need to change the x's to y's, or y's to x's, sorry, and the screen heights to screen widths. So sometimes, you know, it might even be faster to type this out by hand, and it might be probably more trustworthy because, you know, typing can introduce all kinds of mistakes, but in this case, we're only doing it in a couple of places, so I'm not too worried about it. So every height on the second half changes to width, and player pause.x y changes to .x. All right, typing and talking, sometimes difficult. Okay, y, x, x. Screen width, height. All right. Perfect. Now if I go back into Unity, let's drag me over, maybe. I'm going to just move me over here because it's simpler. All right, I'm in the corner. Now if I turn a little bit and fly off this side, woo, I reappear on the other side. Feels pretty smooth. If I go off this angle, the angle continues. Perfect. All right. So my driving is a little bit crazy. Let's mess a little bit with some of our our dynamics here. So on our rigid body, remember I talked about how we would definitely be changing the linear drag and the angular drag. We are going to do that because just going infinitely at the same speed once you hit forward is very tricky. So let's set the linear drag. Let's just set it equal to 1. And I think the angular drag needs to go up just a little bit because turning feels a little floaty as well. So if I push and hold, it takes me a while to slow down, but I do slow down. Turning left, turning right. Feels maybe a little bit floaty, but not nearly as bad as it was before. Now I actually feel like I have some control. I don't feel like I'm just randomly flying everywhere. I do feel a little bit slower now, so maybe I'll increase my speed. But that is one of those great fine-tuning things that you can do with Unity, is just with the serialized fields, I can keep tweaking until I'm happy with it. So you do not have to have your Y velocity and your X rotation set to 100. You can set yours to whatever feels comfortable for you. Your screen wrap for your screen height and screen width may not be the same as mine. I'm not sure. Sometimes it just isn't exactly accurate. So if you go up here and you check this Y value and yours is not 5.7, yours is something else, set your Y, your screen height, to whatever that Y value is so that it will be the same on either side. That stuff is all things that are individual to your game. So we've got movement set up. I think next we'll probably figure out getting some collisions, maybe add some asteroid destruction to our game, not with bullets yet because we don't have any code for that. And I might do some cleanup, just organizing my prefabs into folders because this game's going to get hefty and I don't want to have a bunch of stuff sitting around. So that's where we are now.